Hello folks, welcome to the Sui Move course hosted by MoveBit. I'm Norman, the security researcher and also your teacher of this course. Throughout this course, we'll go through unique features of Sui and Sui Move language, how to implement fungible tokens and non-fungible tokens with Sui Move, and some smart contract example. Ideally, after this course, you'll be able to build, test, and deploy your own smart contracts with Sui. The first lesson of this course will be focusing on the Sui blockchain and also the Sui Move programming language. And yeah, I will show you our agenda. So that's our agenda. Firstly, I will introduce what is Sui and how is Sui different than other layer 1 blockchains. Then we'll talk about the relatively new language, Sui Move, and its novel features. Finally, we'll give you a hello world code example with Sui Move and an exercise for you to figure out why the Sui Move is different than the other smart contract languages. So let's talk about Sui first. First thing first, before we delve into the technical details of Sui, let's uncover what does Sui mean culturally. So, Sui is the water element in Japanese philosophy. The power of the Sui element lies in its fluidity, its ability to easily adapt to and transform any environment. Similarly, the Sui platform seeks to provide a flexible network that you can leverage to shape the Web3 landscape. Sui is a permissionless layer 1 blockchain designed to be both developer and user-friendly. It is horizontally scalable to support a wide range of application development with unrivaled speed at low cost. Next, we'll introduce you some novel features of Sui, such as transaction processing, horizontal scaling, composability, high throughput, low latency, and on-chain storage. Sui's architecture solves pain points in massive adoption. We will explain those features one by one. So first of all, the transaction processing. Sui divides transactions into simple and complex ones and processes them differently. This is because Sui uses the casual ordering method rather than the total ordering. So, unlike most existing blockchain systems, Sui does not always impose a total order on the transactions submitted by clients, with shared objects being the exception. Instead, many transactions are casually ordered. If a transaction T1 produces output projects O1 that are used as input objects in a transaction T2, then a validator must execute T1 before it executes T2. Note that T2 need not use these objects directly for a causal relationship to exist. So for example, T1 might produce output objects which are then used by T3, and T2 might use T3's output objects. However, transactions with no causal relationship can be processed by Sui validators in any order. However, transactions with no causal relationship can be processed by Sui validators in any order. And when we talk about processing different transactions, so when it comes to the simple transactions, actually, most blockchain transactions are simple transactions, such as asset transfer and minting NFTs. And as those transactions are simple, or in another way say, as independent, they can be processed in parallel. But when it comes to the complex transactions, they must be sequenced and go through consensus to be finalized. Sui employs the know-how DAG-based mempool and an efficient Byzantine fault-tolerant consensus via Bullshark. And this will give us the speed we want to process the complex transactions. Next, we'll talk about the horizontal scaling of the Sui. So, on Sui, each group of transactions are processed in parallel. As we mentioned, since Sui is using the casual ordering instead of like the total ordering, if there are more groups of transactions, the validators can add more computing power to increase their performance as needed. Sui scales via intro-validator sharding for more transactions in parallel. But why is this helpful? So this is helpful for a couple reasons. The first one is that the cost is predictable, and the infrastructure can also keep up with growth. So blockchains having capacity limits are going to be a barrier of entry, but Sui's architecture is designed to handle demand spikes. Next, we'll talk about the composability of Sui. With Sui, one is able to pass an asset as an argument to a function and return an asset from a function. And lastly, one can also store an asset in a data structure or inside another asset. Sui significantly improves upon composability at the contract level and also at the asset level, where the objects of different types can be nested in each other. And for the high throughput and low latency of Sui has performed a series of tests to determine current peak throughput on various workloads as well as the time to finality. The test results show that Sui has high throughput with low latency. A Sui network with 100 globally distributed validators achieve peak throughput ranging from 10,871 TPS to 297,000 TPS on various workloads. And that's really a lot compared to other layer 1 blockchains. Sui's time to finality is only around like 480 milliseconds, which is also much faster than other blockchains. Lastly, it's about the on-chain storage. Because assets are directly stored as objects on the Sui blockchain, they're never subject to the Merkle tree indexing like on other blockchains. If you are interested, you can do some research on Merkle trees for further details. Now, let's talk about the Sui move. We'll give you an overview of it in this class. So, Sui move is a superset of the move language designed to leverage the unique features of the Sui blockchain. And Move is a programming language originally developed at Facebook to power the DIM blockchain. Move has several important features. First of all, it is designed with security in mind, and thus it's easy to develop safe smart contracts. It is also a platform-agnostic language to enable common libraries, tooling, and developer communities across diverse blockchains with vastly different data and execution models. And lastly but not the least, Move's ambition is to become the JavaScript of the Web3 in terms of ubiquity. When developers want to write safe codes involving assets, it should be written in Move. Sui has several important features. Let's walk through them one by one. So, as you know, Sui uses its own object-centric global storage. In core Move, global storage is part of the programming model and can be accessed through special operations. But on-chain storage is expensive and limited. Current blockchains cannot scale to handle storage-heavy applications such as marketplace and social applications. So there is no global storage in SuiMove. None of the global storage-related operations are allowed in SuiMove. There is a bytecode verifier to detect violations. Instead, storage happens exclusively within Sui. So in Sui, since it doesn't support global storage, you don't need the address type to represent users' accounts. Instead, the address represents object IDs. As you need a way to distinguish between objects that are internal to Sui Move and objects that can be stored in Sui storage. This is important because you need to be able to serialize and deserialize objects in Move Sui boundary. And this process makes assumptions on the shape of the objects. You can take the advantage of the key ability in Move to annotate a Sui object. So Sui objects have the global unique IDs, and Sui also offers the module initializer function, which we will talk later. Sui also provides an entry function that can be called directly from Sui, in addition to functions callable from other functions. Alright, so let's uncover the module initializer in details. Module initializer is a special initializer function optionally defined in a module, which is executed at the time of module publication by the Sui runtime. The initializer function must have the following properties. It has to have the name init, and it has no return values, and it's all a private function. Okay, so here is a code example of the module initializer. The below codes define a module with the initializer to initialize the admin cap object, and then it transfer it to the contract deployer. So this is a pretty common way to set access control, and we'll come back to this later in this course. The init is called when the contract is published or deployed, and it can be executed only once, as we have mentioned. So those are the novel features of the Sui Move objects. First of all, Sui is a blockchain centered on objects, and it is a basic unit of storage in Sui. Each Sui object has a globally unique ID, and every object has ownership. But before we talk about Sui Move objects, let's discuss abilities first. So abilities are a typing feature in Move and that control what actions are permissible for values of a given structure type. This system grants fine-grained control over the linear typing behavior of values, as well as if and how values are used in global storage. So as you can see here, if a structure C has the drop ability, then C can be duplicated, and without copy, C must be created via pack. If a structure D has drop ability, then D can be discarded. Without drop, D must be eliminated via unpack. Structure K has a key ability, then K can appear in the global storage. And structure S has a store ability, which means S can appear in a field of a key or store type. So finally, structure H, which doesn't have any ability, and we call this the hot potato pattern. So it must be eliminated in the transaction that created. And this pattern is commonly used in the flash loan code example. And we'll come back to that later. Alright, so the Sui Move object is just an instance of a special move structure variable. And it has to have two properties. The first one is the key ability, which indicates that the structure is a Sui object. And the second one is the ID field. This is to store the globally unique object identifier. So as you can see here, the token is a Sui Move object, which has a key ability and also the ID field. Okay, so currently we have four types of ownership of our object. First of all, object can be owned by an address. This is the most common case for the Move objects. A Move object upon creation in the Move code can be transferred to an address. And the second one is owned by another object. So an object can be owned by by another object when you add the former as a dynamic object field of the latter. The third one is immutable object. So anyone can read an immutable object but cannot change it or mute it. The last one is the shared object. So for shared objects, anyone can read or mutate an shared object. And that's a difference from the immutable ones. All right, so SuiMove provides special functions to operate the ownership of objects. Let's see the code example here. The first one is owned by the address. So a move object upon creation in the move code can be transferred to the address. And after that transfer, the object will be owned by that address, and it can be only used in the transaction sent by that address. The second one is a shared object. So also upon the creation, an object can be shared, meaning that anyone can read it or write it. Shared objects require consensus to sequence reads and writes. Let's see a hello world example. So, okay, here is a hello world example in SuiMove. It defines a module, which is hello world, under the named account address hello world. And the second, it imports the dependencies from the standard and Sui framework. So Sui framework is just an extended library for coding with SuiMove. Then it defines the hello world structure to store data on Sui chain. And finally, it defines the entry function to create a hello world object and store the object under the transaction issuer here. All right, so that's a pretty simple code example. Let's do a simple exercise. We love exercise. Right, so I need you to visit the Sui Docs website here to learn why Sui Smart Contract Programming Language is Move and how is it different from other programming languages such as Solidity. So you can pause here and you can check the website, find the answer, or if you didn't have it, you can come back later to the next slide. I'll give you the reference. All right. Okay, so here is the exercise reference. You can check this website to learn why the Sui smart contract language is Move, how is it being developed, and what's the difference between Move and Solidity. Right, thank you. So that's the end of this lesson. I hope you have a good start with SuiMove, and I'll see you next time.